Welcome to the first of the series of exploratory webinars around the theme Complexity, Science and Reality. It's organized by Paralimes in close collaboration with the European Science Foundation. Paralimes means beyond boundaries, and its main activity is exploration. Explorations of dynamics that are already relevant for society, but not yet recognized as such. And explorations of the domain of the unknown, to identify drivers that may become existentially relevant for our future and the future of humanity. Explorations, in short, of what lies ahead of us, to find what we need to know. And true to our name, our explorations are not limited by natural, institutional, academic, or political boundaries, but by imagination only. The exploration around the theme Complexity, Science and Reality are inspired by the thought that in the last 400 years, thinking in the Western world and the organizations of its governments, its universities and its institutions has been shaped and dominated by the philosophies or doctrines of linearity and reductionism. Linearity, and more specifically the linear relationship between cause and effect, created the illusion that we humans can be in control of our destiny. Almost 3 years ago, Paralimes organized a conference around the theme, Illusion of Control. Reductionism allowed us to believe that by dissecting complex problems into simpler ones that we can solve by finding linear cause and effect relationship, that we can then solve the complex problems by linearly adding the solutions to the simple problems. Only since the early 70s of the last century did we begin to see that those solutions do not work. And now we realize that we cannot be in control because of the complexity of the natural, social, artificial systems that we are part of. Partly as a consequence of the technologies that were spawned by our reductionist science, partly as a consequence of the growth in human population and the number and size of its communities, and partly as a result of the interaction between these factors, the complexity of the world we live in, the real world, has grown beyond the human scale, and our natural ways of gaining knowledge, how to deal with it, has lost its human context. As the human-induced problems continue to grow in complexity, and as their consequences transform into existential risks, there is an urgent need for humanity to regain its sense of knowing how to deal with this complexity. For that, we need a new type of science, a science that is not defined by disciplines, but by the potential that emerges from the reality of a messy and complex world. The series of webinars, Complexity, Science and Reality, will take that reality as a starting point. Its purpose is to create a setting in which ideas for new approaches how to deal with the complexity and messy reality can emerge, and to prepare the minds of its participants, you in other words, for exploring such approaches. To lead those explorations, we have invited 9 world-class speakers. You will find their names in the synoptics that we have sent you. Each speaker will be introduced by a moderator, who will then moderate the discussion and subsequently be the speaker of the next webinar. So it is now my pleasure to give the floor to our moderator for today, Professor Sander Van Der Leeuw, who will introduce the speaker of today, Professor Atsushi Iriki. I wish you a very inspiring and enlightening webinar.
All right. Now, do I do something or not? Yes, it is automatically there. Okay. Welcome to this first session in the new Paralimes lecture series of the European Science Foundation. My name is Sander Van Der Leeuw. I am a retired social scientist who has worked both in Europe and in the US, mainly on pluridisciplinary answers to sustainability issues. I've been asked to moderate this session. Atsushi Iriki is an extraordinary cognitive scientist who focused his illustrious and innovative career on the neural basis of language. He started his career by studying the somatosensory processing in monkeys by training monkeys to use tools. In the process, he observed the emergence of tool use behavior and vocalizations associated with specific tools. His current research explores the evolutionary and neurobiological origins of the human mind, and that supports modern civilized society. Using advanced methods in molecular genetics, neuroimaging, and complexity science, as well as ethnological field research among monkeys, he aims to understand how human mental functions emerge from interactions of biophysical systems, and in particular on developmental and aging processes across the lifespan of both humans and non-human primates. His theory on triadic niche construction, which you'll hear more about, postulates dynamic interactions between environmental, neural, and cognitive niches. It examines neurobiological mechanisms underlying the evolution of symbolic cognition, language, inference, self-awareness, and metaphysics. He has come to critique the classic scientific view built on the objectification of reality and linear causality, because it fails to account for the multi-layered causal complexity of real-world phenomena. In pursuing a more encompassing scientific view, he proposes to use an analogy of quantum laws to expand microscopic scientific understanding into the macroscopic human world. By retrospectively examining the evolution of linguistic consciousness, he suggests that human intelligence and civilization evolved analogously to quantum laws, and that quantum computation may eventually integrate natural and human sciences. If so, this paradigm could lay the foundation for a new era of integrated scientific and philosophical inquiry. So welcome to Atsushi Iriki and his path integral approach. Over to you, Atsushi.
Thank you very much, Sander, for a kind introduction. I'm Atsushi Iriki and from Japan. And shall I start sharing my slides?
Yes.
Okay. And how can I do this?
There they are.
Is it shared?
Yeah.
All right. And all right. So the title of my talk, I'm talking about beyond current linear causality that Ian Volter has introduced. This system is looking for optimization of the system, which doesn't necessarily work in a complex world. So as Sander have introduced, I try to incorporate path integral causality, which I inspired from quantum mechanics. But I'm not talking about quantum mechanics itself, but I borrowed the quantum theory to apply to a more complex system beyond the mechanics or physics, but more broadly to the general humanities phenomena. And that means that it's not the linear causation that really matters, but many plausible paths that can arrive to the current status, which didn't happen. Even the ones that didn't happen can affect on what is happening actually. So by doing this, I try to reframe the current way of thinking or current social system to make sense of many things by a path integral causality. So this is as Sander have outlined, this is outline of my talk. And before getting into the core of the complex quantum integral, path integral causality, I appreciate your patience. Allow me to introduce the background, how I reached or arrived to this idea based on myself being the neuroscientist from my own neuroscientific work. As Sander have introduced, I'm very much interested in what makes us human. And I was interested in studying the human phenomena. And this graph on the left depicts the size of the brain back from now to millions of years before our ancestors have emerged. And the yellow ones are species of Australopithecus, which is the ape man. And the brain size from 400 milliliter gradually increased, but not very much. But when the Homo lineage have emerged about 2 million years ago, the brain expansion started accelerated after this. And what made this happen was a puzzling, but we found that this is the point when Homo lineage have started using tools and have evolved many complex tools afterwards, and brain gradually expanded. For this phenomena, I inspired from my old monkey work that brain might have expanded because of the tool usage ability to use tools. So this came from my old study of studying monkeys. You know, these are Japanese macaques, and monkeys or macaque monkeys are thought not to use tools in the natural habitat. But by training, about 2 weeks of training allowed the monkey to start using tools, which was very unusual at that time. It's about 30 years ago. And also the monkeys can even using video monitor. And here's a camera. And this is a monitor on me before he's in front of him. And he's looking at this view. And this is like a video game. And monkey can even learn to use a video game as well. And after this training, I stick the electrode in the monkey brain. This is monkey brain looking from the left side. That the neurons, the nerve cells in the parietal cortex, which is this part of the brain, changes their activity to incorporate the tool into the body image of the hand. Meaning that this shows where the neurons responded to. And this means that the neuron responded when you palpate, touch the surface of the palm, and the neuron fires. At the same time, the same neurons fires when monkeys looked at the hand or something approached the hand. So meaning that these neurons integrate tactile information, which is shown A, and also the visual information related to the hand, and integrate them to form the body image of the hand. And when using tools, this, we call it receptive field, expand to incorporate the tool into the hand image. And also, these neurons respond to the monkey's hand in the video monitor. So this neurons shows extended body schema or the image by training. So this is that tool use training or usage of the tool modifies the brain activity. And by the way, and afterwards, I will mention that this can be the basis of the embodied AI in the future of humans as well. And with this body schema modification, this corresponds to the evolution of the tools in the human Homo lineages. So in this way, the tool usage of the tools pressurize the brain and modify the brain structure and so on. So after this, I'm not getting the detail of this data, but I found by the tool use training, the brain expands, particularly the area of the parietal cortex, where dealing with the language and other more higher sophisticated functions. And when the monkey started to use tools, that modifies the environment. So as Sander has introduced, the three kinds of the niches, environmental niche, the neural niche, the portion of the neural resources, and the cognitive niche, the cognitive ability, interact with each other and gradually expand. So therefore, I call it triadic niche construction. And in this way, I thought it can nicely explain expansion of the brain area corresponding to the tool use and also to the other related functions. And I guess this can nicely explain the expansion of the Homo lineages. But along the line of the human evolution, there's a puzzle called sapient paradox. So which is that along this way, the brain size peaked at before the Homo sapiens. The Neanderthals had a big expand this part larger. So meaning that this is some like 50,000 years ago. But the Homo sapiens have actually emerged like 300,000 years ago. However, during 20,000 years, Homo sapiens didn't do anything interesting. And it's also overlapped with Neanderthalensis. So even though the most lifetime of the Homo sapiens, our ancestors didn't do much interesting things for a long time, most of the time course of their history. But it's only after 50,000 years ago that the Homo sapiens started to do something very much interesting, like agriculture, farming, civilization, art, and so on. And with this, there's a puzzle that why did Homo sapiens didn't do anything at this time, and why did it suddenly start doing the many interesting things? And after that, Homo sapiens' brain didn't enlarge, or rather shrunk. But nevertheless, Homo sapiens started expressing many interesting things. And this was a puzzle. And I did tried many things, but as a conclusion, we found that without physical brain expansion, what has actually happened is a rewiring of already expanded brain areas, trying to integrate many different things and create the new cognitive functions. So in principle, the cognitive niche expands and the neural niche expands by the way of many combinations of the different things instead of actually physically enlarging, and thereby environmental niche expands. So keeping the principle of the triadic niche construction, Homo sapiens in the recent 50,000 years ago, 50,000 years, have exploded their ability to express civilization by rewiring of the things. And these cognitive functions are called domain-specific function. And these integrated function is called domain general function, is that we can do many things alongside, but doing at the same time with other things and integrate things. And these are domain general intelligence, which is called. And why this phase, I call this triadic niche construction phase 1, and this is phase 2. And why is this phase 1 took so long, but the phase 2 is too short, is because of its mechanisms. Substance of expansion of the phase 1 is brain expansion, physical expansion. And phase 2 is just caused by rewiring of the neural brain areas. So therefore, the cost to expand is relatively high compared to second phase. And this is just by rewiring or reconnecting of the existing area, the cost is very low. Therefore, the speed of expansion is low here. And this is also reversible because this is balance of the cost and benefit of the expansion. But after the rewiring, its cost is very low, so speed is very high. And the rule for association of this of this expansion is physical association in phase 1, but in the phase 2, it's a linguistic concept formation. And it's spread by language and spread in social largely in the social structure. Therefore, it is once expanded, it's irreversible. And its phase one, it is reversible because it's a balance of the cost and benefit. So this can explain this long time in phase one and short time in phase two without speciation. In the Homo lineages, but there are many different subspecies of the Homo lineages. But in the Homo sapiens did this without speciation. So the question here is that these previously expanded brain function and areas in phase one is combined in phase two in many different possible ways. So in this way, what is incubated here is, I call it latent capabilities. And these latent capabilities are prepared like exaptation beforehand, and these were combined later in various ways. Therefore, there are many possible paths. It's not just a single way to explain it, but there can be many possible paths. Probably they interfere with each other or interact with each other, and which can be explained in this way. And this is a simplified version of the two element, how it evolves. This is take an example of the tool use and languages. And the blue one is the brain structure for language, and orange one is for tool use, input and output, and green one is the structure in common. So therefore, there are overlap of the two factors. And if the evolution patterns from previous stage to the next stage evolves in many different ways, there are many different possibilities to take where either the language comes first and tool making or tool use comes later, or tool use first or language later. There's many different theories to explain this. And there's always a debate for that. And this is endless debate, and there's always other possibilities. But once it has happened, there remains only one way of evolving patterns. And similar, so this is the combination between, language and tool use. And similar combination can be exhibited in like a settlement and agriculture. There's a debate that we need settlement because we have to do the agriculture, or agriculture started, therefore the settlement emerged. Or there's always a debate, but cannot be concluded definitely. But from this view, there can be many different paths depending on the situation, and both can be true. And giving it a slightly more complex example, the start point there can be variation in the starting point, and these conditions can be changes along the evolution time. And there can be possibilities of many different paths, but it's not the random possibility overlap. There can be some patterns underlying it. And as a result of this pattern evolution, the result can be somehow clustered. For example, at some point of the human evolution, the humans started making huge tombs, like pyramids, and this is a huge tomb of the Japan, and this is in Mexico. And this happened almost at the same time all over the world, but slightly different patterns, but a similar concept, which is the huge tomb. And these can be explained similar to the path integral of the quantum mechanics. So this inspired me to think about the quantum theory might be residing behind that. So for example, from previous state to next state, there are many paths to go through, like using fire, language tool use, cooking, group, or XYZ. And there can be many paths, and depending on the situation, depending on the environment, the human evolution can take many different paths, and all of them can be true. And there can be there must be interfering with each other. And this gives us question about concept of the causality. If you think about, as Jan Wolter has introduced at the beginning, if we tend to think about a causation at a linear causal chain, but if you think that way, and this phenomena, just the way I have just explained, cannot be explained. And a similar question about the causation have been questioned by quantum mechanics about 100 years ago. And there's a long debate about what is a causality and what is quantum mechanics is uncausal. And there's, I think all of you know about this debate. And the Niels Bohr came to the conclusion that there must be causality. At the same time, there's a concept of complementarity, which cannot be explained by linear causation. So this is just a question about what is actually the causality is. And when we think about the causality, as Jan Wolter explained in the beginning, we tend to think about the linear causation, which is by education of the modern science. But the causation itself have the long history, more than 3,000 years, and from the East and West. And for this audience, I think go back to Aristotle is easier to understand. If you go back to the Aristotle, like 3,000 years ago, in his book in Metaphysics and Physics, in a Greek origin, it means like something here, listening to the sound of the nature is the physics. And they call it first philosophy and second philosophy. And Aristotle proposed for the causation, there are 4 causations and different kinds of causation we have to think about. And these 4 causations are not mutually translatable. It's complementary and they coexist, but it cannot be translated by each other. And those 4 causes these are translated in Latin, but causa materialis. This is about the material or things that those phenomena are made of. And causa formalis is but a feature of the structure of the phenomena or forms of the phenomena that this phenomena is shaped on. And the causa movens or causa efficiens is about the mechanisms behind it. And causa finalis is the purpose of the phenomena. And this sounds like a teleology, but it's not actually teleology. But these are the 4 different kinds of the causalities or causes that cannot be translated with each other, but coexist. But the modern science, but 400 years ago, have just focused on this causa movens as the causality, which is a linear causation that we are believing now. So to think about the various disciplines that we are now dealing with. About 400 years ago, where's the cursor? 400 years ago, until 400 years ago, the real world or nature was coexisted observer, which is a scientist, and we are thinking about these 4 different kinds of causes. But after the modern science have existed, their focus or reduced into the mechanisms or causa movens, and other 4 causes have put aside for tentatively because it could not be explained by these causes because these are mutually untranslatable. And the first, by shaping or elaborating onto this direction, we have seeking for unique or universality, universality and abstraction of the phenomena, which is the reductionism. And it's put aside like social sciences by scientification, and also the mind-body problem. We put aside the body and mind from the body, and from the more recently, we put aside the life, which is considers a vitalism and focusing on substance of the life, which is like a molecular biology. In this term, the biology, we call it life sciences, but it's not about the science of the life. It's about the science of the life matter. So we have to call it life matter science or life material science rather than the life science. But anyway, this is a way that how the modern science or Western modernization have focusing or sharpened our concept of understanding of the world. But some 100 years ago, this elaboration hit the limit to face the world of the quantum mechanics. And this structure was no longer able to apply to this phenomena. So therefore, we created, the scientists or ancestor scientists created the quantum mechanics, and which looks like violating the causality and trying to incorporate the idea of the complementarity. But think about this. Probably my gut feeling here was that might be the common principle might reside behind this. And these had been put aside because this is very unique, individual, and unrepeatable, unlike universally repeatable, reversible natural sciences. But the quantum mechanics were considered as a natural science because in the quantum mechanics, we can repeat experiments under the same condition millions of times. Therefore, we can draw this possibility map of the things. However, in this phenomena, we cannot repeat the phenomena in the same condition. Therefore, we say there is not what if in the history. But the general principle behind it might be same or identical, but we didn't have a means to prove it. But the recent few years, the quantum computer have emerged based on the principle or the physical property of this quantum mechanics. But the calculation principle behind it is quantum probabilistic theory, which is not necessarily limited to quantum mechanics. Quantum mechanics is the most beautiful example that this quantum probabilistic theory could be applied. But with a quantum computer, we can make a simulation of this phenomena, which without the quantum computer, it was never possible. We can simulate this phenomena in identical condition in many times and might be able to draw the possibility map of this phenomena, but repeat the phenomena experimentally under the simulation of the quantum computer. And why this can be possible can be analyzed from this way. This is the same figure from we have just seen. In the historical background of a natural science is scientification processes, is reduction of the complex phenomena into the real number space, analogical conscientization. And with this phenomena, we hit the limit of quantum mechanics, and we found action quantum, which is a Planck constant. And with this, to draw this possibility and non-commutativity of the phenomena, we can revive the imaginary axis. In the quantum mechanics, we always need imaginary number axis space to represent this possibility maps. And the central concept here is that non-commutativity and probabilistic superposition and uncertainty and causality and complementarity. And this is mathematically elaborated in matrix mechanics by Heisenberg, and wave function by Schrödinger, and path integral by Feynman. And these three illustrations of the phenomena are mutually translatable. And under this phenomena, probably we can analogously apply the principle behind it. In the world of the quantum mechanics, the phenomena is constrained by the physical reality, which is a Planck constant or the speed of light, and so on. And the quantum computer is designed based on this. But in this field of the phenomena, maybe the mathematical structure or principle behind it is identical, but these constants can be different than Planck constant because we are not reading about elementary particles. And there have been not possible to modify this constant or speed of light in the previous experimental setting. But using quantum computer, we can play around with these constants and parameters, trying to match to the social and mental or psychological phenomena. And probably this is the way that we can play around using the quantum computation and formalize this, the phenomena. So by the way, to explain in the real space, we make the conscientization, make this with consciously explained with natural language. And this is one of the limit or constraint that we are dealing or seeing the world in this natural scientific way. But in the quantum mechanics, we are dealing with imaginary axis, which is verbally not, or it cannot be explained by natural language, but mathematically represented. And this can be computed by quantum computer. So this is the basis of that. And having this background, why we can apply this into the more broad phenomena than the biological phenomena is in this way. Before I talked about this niche construction principle and phase 1 and phase 2, which is physical expansion or expansion of the individual latent capabilities, and phase 2 is interaction or integration of latent capabilities in many different ways. And if you think about more phenomena, this is about individual brain, but as a community, the historical traces is similar. We incubate or develop in each discipline or community individually, and afterwards it starts interacting. And it's same for the civilization. You know, in the civilization, there's a different civilization emerged independently at the same time, and it's gradually start trafficking or communicating or trading with each other. And now we are entering the era of the globalization. So this is like a fractal structure. And the principle behind it, the path integral principle behind it, could be identical. And we can apply the same mathematical principle into this layers of the fractal structure, but governed by the identical principle. And the factors behind it is, as I explained it, it's many latent capabilities as exaptation, and multiple paths, multiple possible or plausible paths to combine it, which comes first, which comes last, and which can be combined. And it's non-commutativity, which is if you change the order of the integration, the result slightly changes. In the classical linear causation, it is commutable, and if you change the order of the calculation, the result is the same. In the quantum mechanics, this was a problem. To solve that, the physicists need to develop the quantum mechanics theory, which is dealing with the imaginary axis space. So in this way, there's a possibility that the quantum computer, quantum computation can deal with this to solve this complexity world. So extrapolating from what we had, just what I have told, the future of the humanities. So triadic niche construction, phase 1 and 2, and we are now dealing with ongoing phase transition by combination of the brain-machine interface, AI, and Internet of Things. And we are now trying to integrate all three niches, unify triadic architectures, and start having embodied AI. And in this world, the linear causation, by explaining by language reasoning, and the goal of this framework is optimization of the things. We try to optimize within this framework, but this doesn't work. So we have to think about the next generation way of thinking and what is next and how can we do that. This next possibility is, and the hint is the path integral causation. So to do that, extrapolating from niche construction phase 1 and 2, since the linear causation and optimization of this way of thinking fails, we have to think about next way of thinking and how to do that. The hint is path integral causation, which just I have described. And for the phase 3, triadic niche construction as extrapolation of the extended embodiment and triadic niche construction, probably it is a quantum computation using quantum computer. This is a schematic diagram how we can expand the causation. This is called a Bloch sphere. It doesn't have to explain that in the detail, but this is what the expression of the fails and true, or 1 and 0 in the classical computation. But in the Bloch semi-sphere, by integrating, overlapping of the fails and true, this is a these are binary or two-value logics that our classical computation are dealing with, and also our linear causation are structuring based on. But with this overlapping of the quantum computation, we can deal with both true and fails, or neither true or fails, or 30% true and 70% fails, that kind of the vague combination. And this can be explained in this expression called Bloch hemisphere. And this can hugely expand the possibility of the causal structure. And we already have the mathematics to do that. Again, I have to emphasize that I am not talking about the quantum mechanics itself, but quantum-like mathematics or quantum-like theory, which is borrowed or the other way around. There are large quantum probabilistic mathematical theory behind it applied to many things. And quantum mechanics is one very beautiful example, can nicely adapt to that. So to expand this quantum theory, I call it quantum-like theory, and we can do the simulation of the historical trait or social complex structure using quantum computation. And we already have a mathematical tools behind it. I'm not getting into detail of this, but I'm just saying that thanks to the 100 years of the past quantum mechanics history, we have many nice mathematical tools to calculate that. And since we have a quantum computer at hand for this 2-3 years, we now have the theory and also the tool to think about, apply this way of thinking to the actual phenomena. So with this theory and tools, what we can able to do is that beyond optimality of the linear causation in quantum systems, we can reframe the next generation operating systems or way of thinking or the making sense of many things, by a path integral causality, which employs many plausible paths, interactions, and interference of that, from linear to path integral causality. So I'm now doing the way, so I don't have a conclusion or result yet. But the idea is that in the comparison of the linear and path integral causality, the causality is linear versus path integral like. And the way of computation is classical computation, which is based on 1 and 0, yes and no, in a classical computer, versus quantum-like computation. And the theory behind it is commutative probabilistic theory versus non-commutative theory. And logic is Bayesian logic in our most familiar linear way of thinking. And this is non-Bayesian logic. And goal of this theoretical structure is that in the linear causal structure, this is optimization of the single path. Versus in this world, these are interactions or interference of the many plausible paths. And description of the simulation in the linear causation is described in the real space, versus in this world is described in imaginary space, or more in more in general way, it's called Hilbert space. This is complex imaginary space, including real and imaginary numbers. And how to prove it? In optimization, we tend to prove by constructing linear construction of the evidences. But like Karl Popper said, we cannot never prove everything. But instead, how the scientists do is to falsify, to do the to seek for the falsifiability of the theories. This is the only way to prove the idea. But thinking about the quantum-like phenomena, it can never prove or falsify by classical computation because it cannot be applied. So what can only prove this theory is by simulation using quantum computer or quantum computation theory. And we name this as quantum falsifiability. And with this structure, we can hope to solve the many problems of the complex system beyond optimality, but interactions or interference of many plausible paths. In this way, the path never happened. Even the path never happened have something to do on the path actually happened by these previous interferences. So finally, so what we can expect to do with this way of thinking is that we can design the next generation operating system, OS, of the society for sense making or making sense of the complex phenomena. And this is my last message, that with change of this mindset to think of many things, we can think about next generation operating system to design and maybe control. We cannot control it definitely in a classical sense, but we can guess and propose to design the future in appropriate way. Thank you very much.
Wow. I don't even, yeah, you can hear me.
Yes, I do. And I'll stop sharing.
Much, Atsushi. This was taking us in outer space, I would basically say. I have been now confronted with your work for the last year or so, and have a number of issues that I think would be interesting to exchange. But before we get to that, are there any people who have asked any questions on the chat? Can you respond to that, Courtney?
Not so far, but I'm reminding people again, if you do have questions, you can put them in the chat and then we can share them. So if the discussion starts your interest and you feel like asking a question, please just add it into the chat.
Elon, I see that you put your hand up. Can you also put your question in the chat? But you can begin by simply saying what you want to say. But you do have to put your yes, that.
Okay. First of all, thank you for a fantastic talk. It's really wonderfully mind stretching. It's the quantum mechanics is, I think, very helpful as a alternate way of getting around the linear causality issues. The problem I have and would love to hear your thoughts on is the question of, if you will, of social friction, lack of a better term, leading to irreversibility, so that one can do the computation in principle, but the complexity itself then is not obviously incorporated in that kind of computation. And the question is how that then, of those many paths, what are the things that constrain those paths because of the sociality that is inevitably present?
So what is your question? The question is that the quantum.
The quantum.
No.
Sorry, let me see if I can rephrase it quickly. The point is that the possibility of deeply modifying the kind of linearity of computation using quantum mechanics, I understand that. That's fine. You have a much broader and much more powerful computation available through quantum computation, but that doesn't eliminate the kind of social interactions which are very difficult to quantify and describe, whether you're using quantum computation or traditional binary logic. Obviously, the quantum gives you much more power computationally, but it does not help us describe the kind of social interactions that make many phenomena essentially irreversible in the sense of any transition in society.
I see. I got your point. Probably you are thinking the quantum computer as a power of the computation, which is called quantum supremacy. But what I'm saying is not about the power of the computation, but the computation principle itself. So how the quantum computation or computer is computing, is the logic behind it is completely different. To your answer to your question, the social interaction that you raised is built in as a phenomena, characteristic of the computation hardware itself. So I call it, it's not just a computation, but it's a quantum simulator. The logic, quantum algorithm itself is representing or simulating those interactions themselves. So using quantum computer is not relying on the power of a computation, but it's a principle behind it. It's completely different, and that must be similar to the social phenomena. That is my point.
I don't want to take up more time, but I think there still is a question of this path integral meaning in a social sense, how one even describes it. I mean, I understand path integrals, fine, but I have a very hard time to understand that in this context, computation or not. But maybe others see this more clearly than I.
Well, this is a difficult question.
Thank you.
So
This is a very, very difficult
discussion,
question.
yeah, discussion can go forever. And I
Well,
think we need time
me
to.
at least say one thing. Imagine, Elon, a group of people who are trying to come up with a solution for something that might lead to an institution. All of them have different opinions. Those opinions ultimately, after a long discussion, end up in a consensus. What I think Atsushi's approach can actually do with path integral logic is to first take all the individual opinions and then look how they are actually going to interact. And to look how they're going to interact in the way in which, in this particular sort of quantum approach, one looks at what is the word here? The way in which the different opinions interact and create a system where a lot of people let go of a lot of their opinions in order to favor a particular one so that they can come up with some kind of a agreement. Now, I don't know if that fits with you, what you are saying, Atsushi, but that is one of the things that I picked up in reading your papers and looking at whether that would be a possible solution. But enough about me. Is there anybody else who wants to come up with a question? No, not at all. Well, then you will force me to ask you a couple of other ones. And one of the ones that I find very, very interesting, looking at linear causality versus the multi-causality that you're talking about, is that there is a difference in point of view. In the natural sciences, generally, we take a distance from our subject so that we create an objective result. One of the really interesting things about your approach is that it actually doesn't do that. It assumes that the observer is part of the world that is being observed. And from my perspective in sustainability, the interesting thing there is that so far we have always argued that humans had a particular relationship with the natural world. But we have treated the humans as more or less identical. And what we have not looked at is the social dynamics in the society that actually create a completely different perspective. And so what I like very much about your approach is this assembling and accepting, for particularly social scientists like me, the fact that people are part of the system they're describing. And that, I think, is another element that needs to be elaborated and that we can talk about.
Yeah, thank you very much for bringing up this idea. So this is another slant that I didn't touch explicitly, but as you said, in the natural science, in the linear science, the observer is outside the system.
Yeah.
And the observation or measurement of the system does not change the system at all.
That's right.
And also observer. But in this view, as a totality, the observer is a part of the system. And when the observer observes the system, that changed the observer as well.
Yeah.
So I think that's the point that you are saying. And
Yeah.
this is, as a phenomenologically, this is actually happening in the quantum mechanics in their value on the constant. But the similar phenomena is happening in the social interaction. as each individual part of the system. And so in this way, the principle behind it is similar. And this characteristic is built in the quantum computation algorithm itself. So it's totally different way than the classic computer to describe the phenomena. So thank you very much for bringing it up. This is another slant that we have.
We need to elaborate this, but just to say a few more words about it. You see, the fact that hard science has always separated the observer and the observed is one of the main drivers why hard science and social science have never been able to agree on anything. Because the fact that the observer is part of the society means that the observer can never objectify and quantify exactly what is happening, because different opinions come up with different results. And so you're touching on a very, very fundamental difference between the natural sciences and the social sciences. And interestingly, your approach moves from the natural sciences, where it was first discovered more than a century ago, into a domain where indeed it can be relevant for the social sciences. Okay.
Yes, thank you very much for rephrasing it. That's exactly what I wanted to say.
That's all right. Any other comments? Please. I see that there is a long thing from Ariane Koenig. Now, this is too long for me to actually read. So I'm afraid, Ariane, you're going to have to say something.
Thank you. That's great. It's really difficult to write questions at this level of complexity of thought into a chat. So thank you for these powerful ways of conceiving the complexification of our brain and our sense making and our imagining across levels of social organization. So it's really powerful, these concepts and the way you think about it. I too have been thinking, but in very different ways, about a science, developing a science, but that is co-designed as imagination infrastructure to help a cultural change to a regenerative culture. And so I'm wondering, let me play devil's advocate. I went the other way because I was thinking many issues we have is from our uncoupling our cognitive processes increasingly from our bodily sense making, and sense making basically across the multiple dimensions of the real life, so beyond the life sciences. So I think we had capabilities as hunter-gatherers of sense-making of our environment in many different dimensions, energetic, relational, ecosemiotics, making meaning of plants in ways we've lost, but with our real bodily senses. And so will improved ways to compute help us to better understand the needs of other species if we want to help the more than human web of life to become more diverse and more resilient again, and fitter for climate regulation with extreme weather events? Do we not need a science that helps us to find back to our bodily senses again, to make sense of material, energetic, and relational change processes, including with the more than human world?
Well,
this is really tackling the core. I'm sorry.
Well, that including today's my talk, my research started from extension of the body,
Exactly.
embodiment. And how the principle behind is how we can extend our body image and body schema. It's not just about a structure, but also the function that how you feel, how we react. And our brain is dealing with our own body, but it has a capability to expand, incorporate other things and extend it. And in the human way, we started to use tools, extension of our hand, and then our memory devices, like a drawing, the memory device, extended hand, and also computer, extended way of thinking. And now we have AI, and so this is.
I understood that. Our imaginary space has complexified immensely.
Yeah. So this is another slant why I'm thinking that this common principle behind it exists, and to further stretch it out. And fortunately or unfortunately, we acquired language to reduce into label the things, and we label one thing, and we ignore other in the peripheral other things. And this is good in constructing a complex structure, but it's bad in recognizing the real structure behind it, which is linguistically unrepresentable, but it exists behind it. So to include this space, natural language is not enough or not adequate to do that. And there's a mathematical structure, and probably if mathematicians are in this audience, they have a sense of acquiring the formula, and we have mathematical tools behind it. And to make it understandable, we didn't have the external bodily tools, but the quantum computer is now we have the tools to visualize that by a simulation. So this is the broad structure behind it.
I completely understand everything you said, and I understand you are seeking a symbolic, abstract, mathematical language that complements our limited verbal language that forces us to think in a linear way, in some ways, more than a complex mathematical language would. But my question is, if part of the problem was uncoupling our sense and meaning making of our environment from our bodily senses that help us to gather a lot of information we process cognitively, consciously, but also subconsciously, will a mathematical language really help us to solve the existential problems we face in terms of inadequately responding to the needs of other species we rely upon for our survival?
Well, that's on the way.
I'm sorry.
I don't have immediate or concrete conclusion yet. So,
okay.
So I'm now constructing a simulator and trying to do the simulation and the intervention to the simulator as well.
Okay. Thank you. Thank you. I'm sorry.
I think I should have said something about that, but all of this, and this goes probably for most of the lectures in this series, it's all work in progress. And what we're sharing is steps in that work in progress. But of course, there is a whole load of stuff around it that would be very interesting to begin to deal with, but we're simply not yet ready. And I think that what Atsushi has done is come up with a huge step forward. But yes, there is still a lot before we can actually deal with that. Okay?
Absolutely. It's an amazing, I really feel deeply enriched in ways of thinking.
Well, that's great.
So
Any other questions? Yeah, sorry, you wanted to say something?
No. What I have proposed is just a different way of thinking. So
Yeah.
I very much appreciate and welcome all your comments. That's enriched my way of thinking for the future. And probably I hope the view that I provide will help to expand your way of thinking as well. So there's interactions or interferences among each other.
Joffa, you
And
want to say something? Yeah?
Yes. Okay, so I'm going to wander through this question and let me see if I can be as succinct as possible. Okay, so thank you for the talk. I've also read one of your papers in which you had a box talking about institutional fatigue and the illusion of causality, in which you referred to David Graeber, who I am a huge fan of. So I wondered if you could speak a little bit more about this concept of latent possibility, because I know Graeber talks about perspective of the unchosen and unrealized social forms, but I get the quantum mechanical theory about the fact that you end up at a certain point, which needs to take into consideration all of the different possible paths, because those paths interact, which is why you end up where you end up. But I'm curious as to how you're reading quantum theory in once you have achieved the second state, what are those lingering remnants of those paths not taken that Graeber is referring to? So theoretically, how would you go back to find a different path? Because all those paths have collapsed to put you into the state that you're in. So tell me more about what you're thinking about how that latent possibility is recoverable, so to speak.
So you mean in to find out those in the actual history on the time back, is it?
Okay, so maybe my question is, could you reinterpret that box that I'm talking about, where you talk about Graeber, in terms of the way you're seeing quantum theory? So are you seeing Graeber's untaken paths or possibilities that weren't realized? Or you're simply saying that quantum theory shows us that that was a real thing that needs to be looked at? Or are you suggesting that when we use this quantum mathematical framework that we are able to recover those latent paths? So are you saying that this is interesting, that the quantum theory gives us an interesting description of paths not taken historically because we acknowledge they exist? Or is there something actionable in the theory that means that those latent paths or those alternative paths that weren't taken are somehow still embedded in the current system such that we could cover them?
Yeah, embedded by the way of interference, or so some sort of how to call it, interactions or interference, or so sometimes maybe regret, or that kind of linguistically undescribable effect. Mm-hmm. And we don't have a tools or ways to describe it yet. And with this simulation, probably we can find a way to describe that. And so this is so what I'm trying to propose is theoretically, by principle, it's linguistically undescribable. So it's difficult to explain in language, and more even so in the foreign language from my mother tongue. But anyway, so I have no concrete answer as well. Okay. I'm sorry, but there's a possibility to do that.
Yeah. It's an interesting question because Graeber has described this. He describes very clearly that there are unrealized social forms. And I think everyone on this call understands that, of course, there are unrealized social forms. And here's just a little bit of just a little comment. I was in Germany a few years ago speaking with some people, and they had a really hard time understanding the concept of plural futures. Because apparently in Germany, there's no such thing. Future does not exist in the plural. And I'm like, but possibilities not taken, or at this point in time, there's multiple possibilities. So which path is it going to be? It was a very interesting discussion because you're talking a little bit about how our language and our training and whatever wires us into thinking in a particular way. So to get to a point where you can't think about futures as being a plural entity, I think
plural, or
it's
always link with idea of the multiverse and the multi-world,
anyway, so I was just curious. I was just curious as to whether or not, when you're actually using the analogy with quantum theory and the summing over the multiple paths, as Feynman says, to get to a particular state, I was just wondering how you were using that latent possibility in terms of recovery of those paths. Anyway, that's it.
It's on the way. It's on the way. So anyway, I appreciate all your comment. But one thing is that if you describe it as a plural future or multiverse or whatever, that is, many things exist, one A, B, C, or D, or not. But what I'm trying to say is that all of them exist. It's not one or the other kind of things. But it's all of them exist in the state.
That's the whole quantum thing. It all exists.
I think that there's some philosophy dealing with that, and we are still on the way of analyzing those philosophical expressions. So I'm sorry, this is just started, and I'm planning to take at least 5 more years to go.
You are touching, Joffa, on an absolutely fundamental point. And reading the Graeber and whatever his name is, archaeologist book, I think the theory is very interesting, but the book shows how difficult it is to do what you want, because the book doesn't really do that. I am very critical as an archaeologist from a lot of their ultimate suggestions, because they aren't very well documented or very well elaborated. And so I think part of what Atsushi is up against is to do that. Now, we will get to that, I think, in one of the next sessions. So rather than have Ilan speak again, because he already has, I'd like to give Victor Wegner-Maus, who has also put his hand up, the next chance to say something.
Okay, thank you. And thank you for the amazing presentation. This is the second time I'm listening to Professor Iriki, and I think it's always been very enlightening and inspiring to listen to these presentations. First time actually was in Stockholm in the Illusion of Control conference when you presented there. So I'm Victor Maus from the Vienna University of Economics and Business, and I do research on computer science and geoinformatics. My question here is that I felt a little bit of a feeling of some missing parts. I understand that the idea is complementary, but perhaps this is for throwing for further thinking. Missing some aspects of the full domain adaptation and mapping from the quantum application to the more social and humanities that you intend to. And that's a little bit related to the previous discussions on where you have the observer in the quantum physics system. You have no probability anymore. The wave function has collapsed, to say, in the language of the quantum physics. So you have no other paths anymore. And while in the humanities systems, you have always the observers in the system already, and therefore the system is already somehow in collapse. So I do not know how to think about this because I haven't thought about this before, but it's to me, it feels some pieces missing on the domain adaptation from one to another of these two different problems to solve. And then I have one question that is to my understanding on, if you could help me on that, what like agent-based modeling could not solve that the quantum equations and mathematical framework could in this case. I'm asking that because we have already very complex applications with agent-based modeling for complex systems with humanities, economics, and many different types of applications, which also have all this distribution of options that come to, give you a probability distribution of things, that possibilities that could come over this system. And yeah, would like to hear your thoughts on this. Thank you.
Well, we haven't done concrete social data yet, but something that we just started is that it's called question order effect. Are you familiar with that? Like in the social opinion analysis, if you make one question and another question the other, if you change the order of the question, the result changes. And this you can, so there's many examples for that, but if you, this question order effect cannot be explained by Bayesian probability estimations. And there's some, and to explain the differences of, and put in this way, when there's in a social survey, probably sociologists recognize that if the question order is different, is it changed, the answer is different.
Yeah.
And to avoid those biases, the usual way to do that is randomize the question order and make an average of that. But if you carefully analyze the question order effect, so there is some phenomena that cannot be explained by Bayesian rule, but it can be explained by the quantum probabilistic theory. And this is one example for that. And we are now starting collecting those data and put it into the quantum simulator. And that's just started, and we don't have a result yet, but it's have a sense of something getting there. And does this answer your question? So we are not grounded onto the actual social phenomena yet. So it's just throwing out on the table the way of thinking. And we are excited that we just have acquired a tool to do that, which is quantum computer. And as a development of quantum computer, to solve the problem of so-called quantum supremacy, to have a benefit of the power of calculation, it's far from that. But now what we really have in the quantum computer is very small scale quantum computer. But the device itself have the quantum probability characteristics. So we are hoping to reproduce those social phenomena in the quantum computation. So that's why I call it quantum simulator. And sorry, the difficulty is we don't have a solid data yet. That's a problem. And we are now getting there. And so
maybe I can point you to some solid data. There is an approach that was started in the 60s in agriculture, where people actually analyze the decision trees by which farmers decide between different crops. And the non-commutability is a very important part of those decision trees. And so I would argue that if you gathered, and I would even be willing to help you with some of them, to actually get a sense by studying that material both in the way agriculturalists study it, but also by the way in which you would study it and see what the actual outcome would be. Because there we know the reasoning behind the non-computability.
I see. So there's a large data set for that?
There is data, and I'm sure there are many more data, because this was an approach that was quite common in agriculture. I have one relatively small data set about it, but I think others can be found. That shouldn't be too difficult.
Oh, thank you very much. That's very much helpful. And
Well,
it's always difficult to find good example to spot the heart of the theory.
You're right. You're right.
And this is the beauty of this structure. It's a multidisciplinary in a gathering of the good sciences from different disciplines.
I think I now have to hand over to Courtney, because we have spent our hour and a half and we don't want to get people in trouble.
Yes, indeed. We're going to have to bring the webinar to a close for today, as we go until 5:30 Paris time. But thank you everybody so much for joining the first webinar today. We really appreciate it. This has been a very vibrant discussion. As we communicated before, this session has been recorded. We'll be uploading it to YouTube in the following days if you want to watch it again, to see more. And keep an eye on your mailboxes and the Paralimes website to hear about the next webinar, which will be in 1 month's time. So thank you everyone very much for attending today.
Thank you very much.
Thanks.